we're going to study electric field now. Now, first of all, what is the meaning of electric field? Every charge, it might be a small charge or a large charge, it has a field around it. And if you bring a small charge near this charge, let us say that it is a positive charge, and you bring a negative charge near this positive charge. Now, because it is a negative charge, it will experience an attractive force towards the charge. So it means that this charge has something around it due to which this charge, it gets attracted towards the first charge. And this field around is called the electric field. And not only is the field associated with this charge, but there will also be field associated with the smaller charge. So it means that whenever you have any charge, it might be a plus charge or it might be a minus charge, they always have a field around them. And this field is depicted by arrows. And for the plus charge, the field is always away from the charge. And for a negative charge, the field is always toward the charge. So, due to this field, a charge feels a force. It's similar to gravitational force. Like now we have Earth here and a small object. So if I throw an object, I leave this object, it will fall towards the Earth. So it means that there is something around Earth. So let me just explain it to you through this drawing. So let us say that if you have Earth and you just leave any object, let's say it's a small thing, something, a ball maybe. Okay, if you drop it, it will move towards Earth. So it means that there is something around Earth which pulls this object down, and this something is, as you all know, is called gravitational field. Yeah, and due to this field, Earth will apply a force which is called the gravitational force. Okay, and this gravitational force is acting on this mass m due to Earth. Similarly, this will also apply a gravitational force, but it will be too small for Earth to move. So if this is m into g, this will be mass of the Earth into the small acceleration with which it moves. Now, because mass of Earth is very, very less, greater than small m, the acceleration will be very, very less than small g. Because these two forces, they should be equal, as we all know, because it's action-reaction force in Newton's third law. Okay. So, in a similar manner, like every mass has a field around it, in a similar manner, every charge will have an electric field around it. Okay, so let us say that if you have a large amount of charge in this sphere, let us say the total charge is capital Q, and you bring a small test charge around it, and this is a very small charge, and we call it as the test charge. Now, because you know that it's the larger charge, so it will have a stronger field around it as compared to the smaller charge. So we don't discuss the field associated with this charge. Now, the electric field by any charge will be defined by the electric force per unit test charge. This test charge is written with the subscript naught, so we write Q naught. So this will be the electric field due to the charge capital Q. Now, as you know, it is electric force per unit charge. Now, what will be the electric force due to these two charges? Now, we have charge capital Q and we have charge small q. And suppose that they are at a distance r from each other. So, as you know that the electric force by Coulomb's law is given by Ke if we are talking about the vector, and it will be capital Q small q naught divided by r square into r unit vector. So from here electric field will be given by Ke capital Q naught upon r square q naught and r unit vector. So this q naught and this q naught, they will cancel and we are left with Coulomb constant total charge r square and r unit vector. Or in magnitude, if we have to say, we can say that the electric field magnitude will be equal to Ke, the source charge upon r square magnitude. So this will be the magnitude of the electric field at any point where there is a test charge. Now, just for notation, we say that this larger charge we are using, we call this larger charge as source charge. We call it source charge because it is the source of the electric field. And the charge we bring in order to check the electric field, we call it as the test charge. And usually it is a positive charge. Okay? And because it is a plus charge and it is a plus charge, so it will apply a force which will be away from it. So this is the force we are talking about here, Fe vector. So this means that the electric field, it depends only on the source charge. Even though there is no test charge, you will still have an electric field. So electric field, it depends only on the source charge and not on anything else. Okay, that's all.